Newton's three laws of motion and Newton's law of gravitational attraction. I'd like to start with Newton's second law, because Newton's first law can actually be considered as a special case of the second law. In Newton's second law, it is stated that if there is an unbalanced force acting on an object, it will cause accelerated motion. As a result, the acceleration of the object will be proportional to the resultant force, and this is summarized in this equation, F equals to ma, where m represents the mass of the object, a is acceleration, and F is the force. We can also rewrite this equation into the form that a equals to F over m. In this form, we can not only see that acceleration is caused by the force, but more importantly, we can see that the mass of the object acts as a resistance to motion. In other words, the mass of the object is an inherent property of the object to resist change in its state of motion. For the same force applied, the object with a bigger mass will accelerate more slowly. Also, as you can notice, both F and A are given in bold letters, indicating that they are vectors with not only magnitudes but also directions. The acceleration will have the same direction as the resultant force. As a special case of Newton's second law, when the resultant force acting on the object is zero, that is, there is no unbalanced force, then according to Newton's second law, the acceleration is also zero, indicating no change in the velocity. We also call it the state of equilibrium. The object either stays motionless or moves with a constant velocity. In this class, most objects that we deal with are at rest. Newton's third law is the law of action and reaction. Let's say object A exerts a force on object B. Inevitably and simultaneously, object B will also exert a force on object A. These two forces will be equal, collinear, and opposite, which means that they will have the same magnitude, same line of action, and opposite directions. These two forces are known as action and reaction, and that is why if you punch the wall very hard, you might get hurt instead, because the wall is exerting the same force back to you. Lastly, let's look at Newton's law of gravitation. Attractive force exists between any two objects with mass. As you can see from this equation, this force is proportional to the masses of the objects m1 and m2, and inversely proportional to the second order of the distance between them, r. The reason why you cannot really feel this attractive force between, say, you and a table is because this coefficient g in this equation is extremely small. But the gravitational attraction force do exist between the two objects, and they are also action and reaction. The only gravitational force that you do feel is the one between you and the Earth, normally known as your weight, and that is the force that will cause you to fall if you are not otherwise supported. The weight is indeed calculated from the Newton's law of gravitation, with m being the mass of the object on Earth, me being the mass of the Earth, and r being the radius of the Earth. Since both the mass and the radius of the Earth can be assumed constant, we can use a small letter g to represent this product of all the constants in this equation. G is calculated to be 9.81 meter per second squared in SI unit system, or 32.2 feet per second squared in the US customary unit system. Therefore, the weight of an object can be simply calculated as m times g. Keep in mind that g could vary depending on the different locations on the Earth. So you might have different weights depending on where you stand.